Alright guys, so this is like unit 1 through unit 3 I'm about to go over, and so one of the things that you all need to remember is at least some of the basic functions. So this one, the square root one, so what does it look like? I would say, and they've been asking you about the x squared one, x cubed. They like asking about the 1 over x one, so just remember what that one looks like. The log equation, the exponential one, okay, the absolute value, that one they like to ask a lot about, so remember what those look like. And so we're gonna go over some of the stuff for it. So one of the things I want you to remember here, and this is not going to be on your formula sheet. Okay, so just remember this little box here. When I see a plus sign, it's going to mean I move to the left. If my number is inside the parentheses or inside the square root sign, the absolute value sign, things like that, if I see a negative sign, it moves to the right. Moves up, and it moves down in the vertical direction if it is outside the parentheses. So looking at this problem right here, I see that the plus 2 is inside the square root sign. So that tells me that this is horizontal shift. And again, what I'm going to do here is make the original equation. So it looks like this before I move it, because I see the plus 2 inside the parentheses or inside the square root sign, horizontal movement, plus sign, so it moves to the left. So it moves 1, 2 this way. So this is the equation I'm looking at, this one right here. Okay, so on what intervals is it increasing? So I'm looking only at the x values, and we talked about this in the chapter 10 also. So I'm starting here at -2, and it's going up here, right? This is moving, you read left to right, it's moving up all the way till infinity. Okay. Is it odd, even, or neither? So even, guys, would be symmetrical about this line right here, and I can see that it's not. It's not the same on both sides of this equation. So this is not even. Odd would be if it looks the same along a diagonal right here, and you can see here it doesn't look the same on both sides. It's diagonal, so it's not odd. This one is neither. And for the most part, you're going to see that most of these equations are neither. Okay, if they move them, they usually are. So any extremas, so it's just this point right here, guys. This is the lowest point that this graph has. So I'm going to put -2 and 0. That's an extrema. And this one right here, since this is the lowest, this is an absolute min. And the parent graph here was the square root. So square root equation. And the transformation that occurred, we already talked about it. It moved 2 to the left, so it moved 2 to the left. And that's all. Okay, so just remember this little square up here. Okay, we're going to use it for the next slide anyway. So looking over here, this is asking describe the transformation. So let's start at least with what's the original equation. So in this one right here, it's cubed, right? So this is my original equation, the x cubed, and I moved inside the parentheses. So this is, I go over here inside the parentheses, so I moved to the left because it's plus. So I moved left 2, and I went down 6. Okay, so we're looking over here. My original equation here is the square root equation, and I moved 2 to the right and 2 up. This one, the original equation, is the 1 over x equation, okay, the reciprocal equation. And the -4 is with the x here, okay, so you can count this as this bits with the parentheses, so it moved, since the minus, it moved 4 to the right and 3 up, because of the plus 3 that's out here. And last one here, original equation is x squared, and I move 5 to the right and 4 down. Okay, so next one here, guys, I'm going to skip part A, this upper and lower bound test. They shouldn't ask you about that. This was something I do believe they will. So they'll probably ask you to list the rational zeros. So really, this is an easy part, guys. I'm going to look at the first number and the last number. I should say the last and the first. This is P, and this is Q. And to find my list, I'm going to divide P and Q, the multiples of them. So if my multiple is 8 up here and 2 down here, what I want to know is what are their multiples. So you put plus and minus. 1 times 8 equals 8, so that's a multiple. 2 times 4 is a multiple, because 2 times 4 is 8. Okay, so those are multiples of 8. And for 2, you have these numbers right here, plus or minus 1, plus or minus 2. Okay. So, my actual list is going to be, I'm going to divide each of these numbers. So 1 divided by 1 is 1. 8 divided by 1 is, this paper's moving here, 8. 2 divided by 1 is 2. 4 divided by 1 is 4. And then I'm going to go back. 1 divided by 2 is 1/2. 8 divided by 2 is 4. It's already part of my list, so I don't have to write it again. 2 divided by 2 is 1, so again, I don't have to write that number again. 4 divided by 2 is 2, already part of my list. I don't have to write it again. So these are my possible zeros. Okay. Okay, so I'm only going to go up to this part. We're actually, this shouldn't be part of here. I don't believe they'll ask you about that. Factor these equations. Actually, factor these equations. So this is my original equation. So what I'm going to use is synthetic division. And so let me get the numbers. I'm just getting these numbers. 2, 7, negative 7, negative 8, 14, and positive 8. And if they don't give you like a clue on what numbers that I'm going to divide by, well, I'm going to use these right here. So you're going to have to go one by one until you find a number that actually works. So what I'm looking for is which one has a remainder of 0. So I'm going to start with a positive 1. So I'm going to divide by positive 1. Okay, so this number is always going to come down. The first one always comes down. And now I want to multiply. 2 times 1 is 2. So then I'm going to add negative 7 plus 2 is negative 5. Negative 5 times 1 is negative 5. Negative 8 minus 5, negative 13. Negative 13 times 1 is negative 13. 14 minus 13 is positive 1. 1 times 1 is 1. So here I have a remainder of 9. So this is not a factor. This is not what I'm looking for. And I would have to keep going one by one. So I try negative 1 next. I've gone through this problem already, guys. So we're going to try factoring the negative 4. I'm sorry, positive 4. Let's see if this one works out. So here, bring the 2 down. So 2 times 4 is 8. Negative 7 plus 8 is 1. 1 times 4, positive 4. So there's going to be a negative 4 right here. Negative 4 times 4 is 16. Negative 16. So 14 minus 16. Oops, sorry about that. 14 minus 16 is negative 2. Negative 2 times 4 is negative 8. 8 minus 8 is 0. So this is what I'm looking for. This is a factor, so the way I would write it is x minus 4, so you do switch the sign. And now I start writing this part. So 2x, and there's going to be a power down from this over here, so there's going to be 2x cubed minus x squared minus 4x minus 2. Okay, so this is the factored form. Okay, so last few slides here, guys. Solving exponential equations. So what you need to remember is using the one-to-one rule. So I can solve like the top part if they have the same base. And here I can see they're not the same base. They're a little bit off. Okay, and so I can see that I can leave the small one alone. So it looks like that. And let's say 9 is the same as saying 3 squared, because it is. Okay, so what I'm going to do here now is put what I have already. So 2x minus 3, put it right here. And now I have the same base, 3 and 3. So now I can pretty much cancel them to get rid of them. And I can solve for x. So I'll distribute this. This is 4x minus 6. X plus 1 over here. So I'll put all the x's over here. So minus 4x minus 4x. So x minus 4x is negative 3x plus 1 equals negative 6 minus 1 minus 1. So negative 3x equals negative 7. Divide by negative 3. So x equals negative, excuse me, the negative cancel out 7 over 3. Okay. So I'm going to leave it like that, guys. This one, on the online, I'll go ahead and have this one worked out, but I'm not going to go over it in the video. Okay, same thing. So next thing is to solve log equations here. So what I really want to do here is put anything with a log on one side of the equation. Okay, and so that's what I see here. I see I had log over here, I see a log over here, so I'm going to subtract log 4/2. So it goes away here. Log 4/2. So I'm going to write the long way here. Okay. So what I have here is an equation now that I can solve. Okay, and really you need to remember your rules for logs. So if I see a minus between them, that means I divide the numbers. So log base 4 8 over 2 equals 1. So log base 4, 8 divided by 2 is 4, equals 1. And here, what I want to do, I don't have an x to solve for, but this should say, I think this should have had an x, actually, because I'm solving for it. So this is 4x. So now I can solve. So this is 4 to the power of 1 equals 4x. So 4 to the power 1 is just 4. And now I can divide by 4. Divide by 4. X is equal to 1. Okay, and I'm going to go ahead and change this problem here. So I'm going to add an x down here. And you erase this. So one thing that I can do, guys, you see how I have log with the same base on both sides of the equation? What I can do here is cancel the logs like I did with the exponential. So here I have, well, first I need to put this up here on top. Okay, so if I have a number on top, you bring it up. So this is log base 2, 2 to the third power equals log base 2, 2x. Okay, so here log base 2, 2 to the third power is 8. Log base 2, 2x. Okay, so now I can get rid of these. 8 is equal to 2x. So I'm going to divide by 2, x is equal to 4. Okay, so again, guys, just keep a lookout for the other videos, and if you have questions, bring them to me in class.